All right, let's talk about statistics, but I want you to forget about dusty old textbooks for a minute. Today, we're going to see how a few foundational ideas can take the complete chaos of a clinical ward and transform it into clear, actionable insights that can genuinely improve how we care for our patients.
Okay, before we really dive in, a quick but really important note. A huge thank you to Dr. Abdul Karim for providing the materials for this analysis. Now, please remember, this is a study aid. It's a supplement to help you review the concepts. It absolutely does not replace attending class. So for any specific questions you have about the course material, make sure you use those Q&A sessions or reach out to Dr. Abdul Karim directly.
All right, let's set the scene. Every single one of you in nursing is going to face this challenge. What do you do with the overwhelming amount of information that comes at you every single day? This is the fundamental problem that statistics is here to help us solve.
I mean, just picture your typical day on a ward. You've got a patient with a fever, lab results just came in for another, someone's blood pressure is 140/90, the patient in room 3 is alert, a med is doing 10 minutes, and another patient is reporting a pain level of 7. It's just this constant stream of critical information, and when it's all coming at you at once, it feels like pure chaos. It's a state where it's way too easy to miss something vital.
Okay, so to begin taming this chaos, we have to start with the absolute basics. First up, the case. Now, in any study, this is just the fundamental thing you're observing. For us, in our world, it's simple. The case is our patient. That's who we're focused on.
So if the patient is our case, then a variable is any characteristic of that patient that we can actually measure. Things like their body weight, their age, or their reported pain level. These are the specific data points we collect to understand what's going on.
Remember that chaos we were just talking about? This, right here, is how we fix it. We organize that exact same information into a structured format called tidy data. And look what happens. Suddenly, the chaos becomes clarity. We can easily see each patient and the value for each variable we're tracking. And this isn't just about being neat. This is about patient safety. Untidy, disorganized data can lead to serious medical errors.
And you know the rules for this are incredibly simple, but they are so powerful. In a tidy data set, every single column is one variable, like temperature. Every single row is one observation, so for us, that's one patient at one specific moment. And every single cell holds just one value. This structure is the absolute foundation for making sure we don't misinterpret what the data is telling us. So, now that we have our data all organized and tidy, how do we start to make sense of it? This brings us to a really helpful way of thinking about statistics in a clinical setting. I like to call it the clinical lens metaphor. Just imagine each variable, temperature, blood pressure, pain level, is a different lens that we can use to look at our patient. A thermometer gives you one very specific view of their health. A blood pressure cuff gives you another. A pain scale gives you a third. Each one of these lenses reveals a different, crucial piece of that patient's story. But here's the thing. Just like a microscope and an X-ray give you totally different kinds of information, different types of variables do too. Not all data is created equal. So to know which tool to use for analysis, we first have to understand the properties of the lens itself. And we call these the levels of measurement. And lucky for us, there's a fantastic little mnemonic to help us remember the 4 main levels. Just think of the French word for black. N-O-I-R. That stands for nominal, ordinal, interval, and ratio. Let's see how this actually builds on itself. It's a hierarchy, where each level adds a new property. So down at the bottom, you've got nominal, which is just for naming categories, like a patient's blood type. Then ordinal adds an order to those categories, like a pain scale. After that, interval adds equal spacing between the values, like temperature in Celsius. And finally, at the top, ratio adds a true, meaningful 0. So why does any of this matter so much? Because the level of measurement, the type of lens you're using, sets the rules for what you're allowed to do with the data. It determines what kind of analysis will give you a meaningful, clinically relevant answer, and what will just give you nonsense.
This table here just breaks it all down perfectly. You can see that progression so clearly. Nominal data? Nope, no order. Ordinal adds the order. Interval adds the equal spacing, and ratio adds that critical true 0. And now look at that bottom row. This is the payoff. It dictates the kind of math we can do. You can't calculate a meaningful average blood type, right? But you absolutely can calculate an average weight.
Let's make this crystal clear with an example you'll see every day. On the left, a pain scale. That's ordinal data. A patient's pain at a level 8 is definitely higher than a 4, but can we say it's exactly twice as much pain? Of course not. The distance between those numbers is subjective. Now, compare that to body weight, which is a ratio variable. A patient who weighs 100 kilograms is, without any doubt, exactly twice as heavy as a patient who weighs 50. Why? Because a weight of 0 means the complete absence of weight. It's a true 0, and that's what allows for true ratios.
So here's the crucial takeaway. Getting the level of measurement wrong isn't just some abstract statistical mistake. It's a clinical one. It is exactly like trying to take a patient's temperature with a stethoscope. It just won't work, and the information you get will be completely meaningless, which can lead to really bad decisions.
Okay, so we've collected our data, we've organized it into a tidy format, and now we understand its properties. What's the final step? Well, it's to communicate what we found. We need to tell the patient's story using one of the most powerful tools we have, data visualizations. You're going to see two charts all the time, the bar chart and the histogram. They might look similar, but their purpose is entirely different. You use a bar chart to compare separate categories, like patient outcomes on drug A versus drug B. You use a histogram to see the spread or the distribution of a single continuous variable, like the whole range of ages on your ward. Choosing the right chart tells the right story.
The easiest way to tell them apart just by looking at them is to check for gaps. Bar charts have spaces between the bars, and that signifies that the categories are distinct and separate. But in a histogram, the bars are always touching, and that's on purpose. It's showing you that you're looking at a continuous, unbroken range of values and where your patients are falling along that spectrum.
So, from the initial chaos of the ward, to tidy data, to choosing the right analytical lens, and finally to visualizing the results, every single step we've talked about is really about one thing: uncovering the story that your data is trying to tell you about your patient's health. The only question left is, are you equipped to listen?